Hi students, Mr. Halpern here. In this video, we're going to go over the ideas of isotopes and how we can identify them both in symbols and also using the periodic table. And then we're going to go into a chart where we can have protons, electrons, neutrons, atomic number, and something called mass number. And we can identify some ways in which we characterize an atom. So just to recap, last time we talked a bit about ions and ion capacity, right? Exchange capacity in soils are very important because we want to make sure that we're able to hold a certain amount of nitrogen, phosphate, and potassium ions particularly. These are macronutrients that are needed most in the soil. And so we want to have a high exchange of these. In other words, we want to be able to hold these nutrients longer. Now, that could potentially be problematic if it's something that's toxic, right? Like, for example, arsenic or mercury. But that is a little bit less to do with ions because those are less ionic. Now, moving into ions, right? What is an ion? We're going back for a second. An ion is really missing or extra electrons. And we drew an atom to help us understand this concept and sort of visualize an electron particularly missing or being added, in this case being added, which caused lithium, this particular atom being depicted, to be a negative charge. And we had also a way of describing the amount of protons as a way of identifying also the type of atom as a particular element. And the atomic number is the number of protons. And we then filled out this chart here that you can see. And this chart has protons, electrons, atomic number, and charge. Right? Now what we're going to do is add more into the neutrons and the idea of neutrons. Okay, so we're going to jump into that right now. Okay, so if we were able to go to a periodic table, which we can, you would see, oops, my daughter was playing with the pens here. Let me just change this really quickly. That carbon is a particular element whose atoms have atomic number of 6. Okay, what does that mean? That means it has 6 protons. So if I were to draw an atom, right, of carbon, I could say 6p. Instead of me drawing the individual dots, that's a lot of dots we're trying to get to, it'd be 6 protons. And then we're talking about inside of the nucleus here, right? So this could be inside of this nucleus. And then we have electrons on the outside. Okay, so we have 6 protons here. And then we also have 6 electrons. If this is a balanced atom and it's neutral, then we would draw 6 electrons. And just for ease, I'll make sure I write electron as a negative sign, and E represents electron. And for this purpose, for our purposes right now, I won't get into why it's 2 and then 4. Just know that that total is 6, and protons are 6, so it's a neutral atom. Well, what are we missing here? We're missing neutrons. So neutrons, if we're talking about a stable atom, we have 6, the same number as protons and electrons. So one way we can write or characterize carbon, because it's important to know the neutrons too, we can sometimes write carbon dash, and then it's the number of protons plus the number of neutrons, carbon dash 12. Sometimes we write, for other atoms like uranium 235, right? Or uranium 238. These are very specific numbers of protons and neutrons that determine whether or not it's radioactive, for example. What does that 235, 238, or in this case 12 mean? Well, this is something called the mass number. Okay, and the mass number is the number of protons and neutrons. And a note here is that if it has more or less neutrons than the protons, in other words, if the neutrons is not 6 in this case, if it was 5 or if it was 7, it would be considered unstable. Okay? And so that's important for us to note. So we can even draw that here. Let's make sure that we draw an example here. Let's say that we have another example of all of this. Okay, so we have that here, and we have 4 electrons. But instead of having 6 neutrons, let's say that we have 7 neutrons. Okay, what would this be called? Well, this is now no longer carbon 12, this is carbon 13. Okay, and this is considered radioactive. It's not as common as carbon 12, but we can also use radioactive isotopes to help date something, radioactive dating, right? Carbon dating is actually using isotopes of carbon, and they will have a half-life and they'll decay over time, right? And we consider this to be unstable. So it's radioactive, and it's an unstable nucleus which decays. Right? We have radioactive decay as a result of that, DE. Okay, so that's important. So one last sort of thing here is that we would call these isotopes. So isotopes are atoms of the same elements, but that have different numbers of neutrons. In the case of carbon 12 with 6 neutrons, carbon 13 with 7 neutrons. Okay, so that's important, and that's an example there. And now what I want to do is just practice just a little bit. I want to go into some examples here. Okay. Okay, so let's take a look. All right, so if we have, let's do this one right here. Let's do sulfur, right? So sulfur 32. A couple of things that you notice there. Okay, the sulfur 32. The 32 is written on the upper left-hand corner. So if you go to your periodic table, right, and you look at sulfur, and you might be thinking, well, why is it 32? I noticed that sulfur has an atomic number of 16. Where did I get that? I got that from our periodic table. Huh, what do you think that 32 is? Take a guess. 32 is the mass number. And if you didn't notice that, sodium above that had 23, right? Upper left, and its mass number was 23. Okay, so if the atomic number is 16, the mass number is 32, what's the protons? Ah, we remember that protons and atomic number are the same, so it'd be 16. I notice that there's no charge on this atom over to the right, and so I'm going to assume that the protons and electrons are balanced, so they're also 16, and that the number of neutrons is somewhere in the mass number, and the protons are with that. So if there's 16 protons and the mass number is 32, it does 16 neutrons. All right. So let's try the next one. How about silver 108? So silver 108 is, as we said, the 108 is the mass number. Silver's atomic number is 47. And so we know that that is, again, the number of protons. We know that there's no charge, so we assume that it's 47. Now, how do we figure out the neutrons? Well, if the number of protons is 47 and the mass number is 108, we subtract 47 from 108, and what do we get? We get 61. Okay, so that's how we do those two. I just wanted to give you a few examples. What I'd like you to try to do is fill in the rest of this chart here. Okay, so go ahead and pause and write this out. I want to see how you do. All right, take care.